So we'll start the class. Again, good morning to everyone. As and when possible, it's better if you have the laptop with you so that you can practice with the notebook that I have shared in the Google Classroom. The video of last class will be shared by today evening because there were some issues in uploading. So that I'll be sharing later. So I think we have seen up to creating NumPy arrays in the last class. Am I right? Is the presentation visible? How many of you are attending from your smartphones and how many from your laptops actually? It's fine, you can do the program in both devices, but visibility will be more. So if you are not able to see something, I can increase the screen size. Is anything required? Okay, I guess it's fine. Okay, then I'll start. So this is the thing that we stopped last class actually, creating NumPy arrays. Okay, so the key feature of NumPy is its n-dimensional array or ND array having the below specialities. So you can just read through the things that I've written there. We'll just go through the programs. So I'm just naming an NumPy array as ARR and I'm calling this with NP since I have imported NumPy with this keyword actually NP. So now I'm calling NumPy as ARR equal to np.array of mylist. Okay, so this mylist has been created in last class. If you want to see what it is, this is my list actually. Okay, so I'll run this cell. So when you're starting your program, you just check whether your notebook is connected to the Python 3 Google Compute Engine backend. Okay, so just see that and I'll just display what is my list presently, and we'll go with that same list actually. I am giving that my list here and I am putting it as an array using np.array. Okay, and then I'm printing type of ARR. Then I'll get like, when I run the cell, I'll get like np.numpy.nd array, and the array is also displayed. Okay, next I'm just listing some lists actually. I mean my scalar I'm getting as 1 2, so one by one we'll see what it is actually. Then I'm just naming this my scalar equal to 12, my list 1 equal to 1 2, like that I am providing these values. Okay, if you have the notebook with you, you can also see. So I'm just seeing like my list 1, I'm just seeing the dimension of my list 1. If I run this one, I'll get like my list 1 has a dimension of 1 actually. Okay, now if I put my list 2 in the same thing, what I'll get, we'll see, it has a dimension of 2, and my list 3 if I am putting, then my list 3 is now stored as is an array having 3 square brackets, consecutive square brackets. So we'll see how it is coming, like what is the dimension of that my list 3 coming as. Okay, so if you see that the dimension of this my list 3 is 3. Okay, so one way to see what the dimension of your list is, like see the number of consecutive opening or closing brackets. So if you see here, there are three consecutive opening brackets. Okay, so it's one way of saying there can be extra dimensions in between the arrays. So for clearly knowing that, you should use this ndim function actually. Okay, now next I'll create a Python list having a sublist of values. So I'm just giving like my mat equal to this list. Okay, and then from there I am creating a numpy two-dimensional array. Okay, so how to create that one is like I'll just give mat equal to np dot array of, I have just given the list as my mat. Okay, so I'll just give my underscore mat. Okay, it will show you the suggestions directly, so you can click that also when you start typing. So mat equal to np dot array of my mat. Okay, then I just want to display the type of my mat variable and then output the values also. So if I run this cell, you can see that you will get the array, this one as a numpy dot nd array, and the array which we have given will be displayed like this. Okay, now if the dimension of this one is required, we'll just do like np dot array ndim. So why this is coming as 2? Look at the opening and closing brackets here. Two openings consecutive brackets are present there. Okay, now the observations about this numpy arrays is that they have the same functionalities as Python list, but the difference lies in the functionality and speed of doing the operations. So about the speed, we have seen a program earlier like the speed check, when we were using just the Python list for an operation, and when we were using a numpy for the operation. So this was done last class. So here we have found that the numpy version runs very much faster than the pure Python list version. So that is one of the things we can observe from it. Then the important difference in working with numpy array is that, sorry for the typo. So difference in working with numpy array is that it's more convenient and fast. Then nd arrays are used for handling images. Later when you have to work with different images, you can use this nd arrays, and it's easier and faster to do any image operations in numpy arrays as compared to Python lists. Okay, now if you want to check the different array attributes, okay, so these are some of the attributes that you can check here, like shape, ndim and dtype. So shape will give the information about the dimensions of an nd array. Then ndim will give that information about the resolution, and dtype will give it the information about the type of layout of data being stored by the nd array. Okay, so each one we'll see one by one. So I'm just giving this ARR. This was input earlier actually. ARR we had stored as an array earlier, which consists of the elements 1 2 3 4 5. Okay, so I'm just printing the ARR here. Now after that, I'm just doing this one also. Once again, I'm giving these inputs to my mat, and I'm making my mat as a numpy array, and I'm just displaying that too. Okay, just repeating the steps that I've done earlier. Now I just want to see what is the array shape and what is the matrix size actually. Okay, so what I'll do, I have just put this string actually, just giving array shape, and now I have to give the command. Okay, so what command I'll be giving? I'll be giving ARR. First I'll want to see the array shape actually. So I'll give the name of the array space AR dot shape. Okay, now if I want to see the matrix shape, I mean the my mat shape actually, I have stored it as mat. So I'll do it like mat dot shape. Okay, Now if I run this, you can see the array shape. The array shape is like 5 elements were there, so 5 comma nothing is there. Okay, now the matrix shape is coming like 4 comma 3. So here complete shape is there like for a 2D array. So this is like 4 rows are there and 3 columns are there. Okay, then the earlier one, since only one dimension was there, it's displayed as like this only. Okay, now if you want to see the resolution, similarly you can just give like arr.endim, and for the matrix resolution mat.endim. Okay, these are all simple stuffs only. You can just go through that in your notebook also. Then the next one is the type of the ND array. Okay, so if I just give like arr dot, how to see the type, you have to type d type. Okay, so anything you have to do in this array is just listed here. So if you just type d, then it will show you the different options. So just click that arr dot d type. Similarly for matrix you can do like mat dot d type. Okay, this one will also show you the different options available. If you run this thing, you can see the type. So both the arrays are of the integer type actually. So if I do one change here, like if I put a character here within inverted commas, then I'm just running this program, so it will come like G here, and the type, it has changed now. Okay, so I'll just run this again. If I run this again, the matrix will be coming like this one. That will include the inclusion of the string character. Okay, so if it was an integer, it would have come as what? It would have come as the int 64. Otherwise it will come as u21. Okay, so I haven't run this thing actually. Okay, I have run this, and now if I run this, you'll get int64 itself. Okay, so it's observed now that it's easy to make use of shape, endim, and dtype function to check the shape, dimension, and data type of the array. Okay, next we'll move on to array initialization. So these are the different things by which you can, by the different ways by which you can initialize an array. Okay, so first one is a range, then zeros, ones, linspace, and I. So each one will look in detail. So the first one will be like np. If I want to create an array of size 10 with a step size means it should increase with the size of 1, so it should come like 0, 1, 2, 3, like that it should go. So I'll give like np.arrange 0 comma what should be the ending number. So that I'll put the next entry, and the third entry I'll give as the step size. Okay, so if you give like this, what will happen is that it will print up to 9 only. So the parameter that we are giving here will be excluded. Okay, so if you want to include 10 also, you should give as 0 comma 11. Okay, so if you give 11 and if you print this one, it will show like 0, 1, 2, 3, etc. 10 is also included. Now if you want to create an array of size 10 with the step size of 2, what you should do is that you can just change the step size here and you can just run it. Okay, so you can see that the step size is 0, 2, 4, 6, 8 and 10. In between there is 0 is there, 0 to 1 step size, and 1 to 2 another step size. Okay, so this is how the step size works. And if I want to generate an array of size 4 containing 0, so this is the next type actually. First we generated an array of specified range and step size. Next we are going to create an array which contains only 0 values according to the size that we give. So if you want to give an array just having zeros of the specified size, you have to put np.zeros, okay, and you have to specify what the shape is. So I'll just give like shape is equal to 4. If I give like that, okay, sorry, so what is the problem is that I'll just do it, okay, wait, okay, so np.zeros, the shape is coming as 4, okay. So the earlier the error that came was like one indentation was there. If I run this, I mean it will explain whatever error is coming, you can check what is coming actually. So it has given like indentation error, unexpected indent. So what I've given that is that I have mistakenly given a space here actually. So you just remove that space and you can run it, okay. Whenever you are getting an array, the Python itself will be prompting you which error you have done, okay, in most of the cases. In some complex cases you might have to go to search Stack Overflow or other sites, okay. Now if you want to create an array of size 3 by 3 containing zeros, the same thing you can do with shape equal to, you can put 3 comma 3, okay, and I'll just see the resolution and the output. So if I do that, you can see the array was created with 3 rows and 3 columns, and all the elements inside are what you say zeros only, okay. Now similarly, I just want to create an array which contains only ones. So if someone can tell me what the command that I have to use is displayed also, you can type in the chat window. What should I do if I want to create an array of size 3 by 3 containing ones? Please respond. I'm audible, right? Okay, it's ones actually, np.ones. You can put it like shape equal to, it's better if you do like that, shape equal to, you can put 3 comma 3, okay. So if you run that, you can get like array 1 comma 1 comma like that. So you have created a 3 by 3 matrix, 3 by 3 matrix with array with the elements as 1. Now if you want to generate it just simple only, if you want to generate evenly spaced numbers from 0 to 5, this is the another thing, like the numbers will be generated which are equally spaced. So this is the start number, stop number, and the number that should be the number of equally spaced numbers to be generated is given as num equal to 20. So if you run this, you can see like these many numbers between 0 to 5. So in linspace, if you give the start as one number and stop as another number, both these numbers will be included in the final result, and the number equal to 20 denotes how many equally spaced numbers will be there. So 20 will be here now. Now if you want to generate a 2D array with ones on the diagonal and zeros elsewhere, then I is the command that you have to use, np.I. If you specify n equal to 3 and m equal to 3, you will generate an array only having the diagonal elements as 1. So this is one thing that you can use in many signal processing operations, okay, and as a filter or mask in many operations actually. So Next one is random array initialization. So here what we'll do is that there are two commands actually. Okay, we are seeing how to populate array with random numbers. So rand function will create an array of given shape and populate with random samples of a uniform distribution. Okay, so that is created when you give rand, and if you give rand n, then you will get a standard normal distribution of mean 0 and variance 1. Okay, so I'll just run these cells actually. So first I given like np.rand random.rand of 5. So if you want to call this function rand, you have to put np dot random.rand of 5. Okay, so if I give that, I'll give an array of 5 random values. Okay, next if I give np.random.rand and I want to create an array of 2 by 2 resolution, then I'll give like np.random.rand 2 comma 2 actually. Okay, now for example this same thing can be used to generate an array, and I just want to get an array of resolution 4 by 4. So what I should give like 4 comma 4. Okay, so if I give like this, you can see np.rand 4 comma 4, 4 rows and 4 columns have been created. Okay, next one, just I've given these things, you can just go through this later. So I've given like np.random.rand 6. Actually I have stored in rand underscore array. Next I'm seeing the elements in that random array, and I'm just using ndim to see the resolution of the array that I've created. Okay, so till this one I'll just run this cell alone, and later we'll do the other one. So you can see the random array has been created with 6 elements actually. Okay, and its resolution when given as n by ndim is coming as 1. Now for other purposes, if you want to reshape this array, okay, this is an 1D array actually, so its dimension is coming as 1. Okay, now if you want to reshape it to a 3 by 2 array and you want to see the result, what you have to do is you have to take its name. So because already we have defined it as an np.random.rand array actually, so you have to just take that name and put reshape 3 comma 2. Okay, so if it's done, you can see whatever has been in this 1D array, it has been reshaped to an array with 3 rows and 2 columns. Okay, so how the ordering is it comes with the numbering of the 1D array itself. Okay, then next one is normal distribution. So till now we have seen the uniform distribution actually. The uniform distribution, the values will range between 0 and 1 excluded actually. Okay, now for normal distribution you have to use this command actually, rand n. Okay, and I'm just printing a random array with 1000 elements actually. So if I do that, and it's generated actually, I'm not displaying it because it will be a huge array. So what I'll do is that this I have stored this np.random.rand n 1000 elements like that. I have just stored it in leg array. Okay, so just we'll see how is the shape of that array without printing the whole array. We'll see what is the shape. Okay, so if you do that, what is coming is like there are 1000 elements in that array and it's a one-dimensional array. Okay, if you just want to know the resolution of that also, you can just give like ndim. Okay, like array.ndim, you can see it's one dimension only, but there are 1000 elements. Okay, now this particular next cell I have given, this one is for another operation actually. So what I'm doing here is that I've told you, no, this is a random normal distribution. So I'll just show you a picture. If it's not visible, tell me. So this is the normal distribution curve actually, bell distribution. Okay, bell curve. So here you can see that mu, this is the mean of the normal distribution. Mu plus sigma and minus sigma. Sigma is the standard deviation. Okay, so mu minus sigma and plus sigma. Between these two values, it is known as the first sigma or 1 sigma area. Okay, so this much area will include about 68.27% of the values. Okay, so in a anywhere, if you are forming a normal distribution with elements, that elements you are storing into an array, about 68.27% of that elements will fall in this category. This category means between mu minus sigma and mu plus sigma. This is the 1 sigma area. Okay, now if you are taking like that sigma value between minus 2 sigma and plus 2 sigma, it will contain the value of 95.45%. that is the 2 sigma. Okay, and if you take 3 sigma, it will be containing about 99.73% of the values in that normal distribution. Okay, so I'll just say here what I'm doing here. So I have given like array.ndim like this one. Okay, now I'm just giving like this same array I want to take, but in that array also I just want to see the values which are greater than minus 3 and less than 3. So I am aiming for this portion actually, 3 sigma and minus 3 sigma. Okay, so if I do that and if I just get the shape of that one, you can see that about 998 of the values in this particular array is in between these values. Okay, so what does it mean? In this portion, if about 1000 elements are there, so 0.998, that means 99.8 number of the elements of our random normal distributed array is falling in between minus 3 and plus 3. Okay, so if I just put minus 2 and plus 2, you can get this shape, and if you see the shape, you can see that 96.5. It's little more only, 95.45 is here, it's 96.5. Okay, so likewise you can find out how many elements are there in the random array. This is just for an information. Now next, if you want to see what is the mean of this array, okay, just I'm taking like array dot mean. Okay, so the mean is somewhere coming, it's coming close to 0, 0.023. Okay, so some difference will be there. Now just what I'm doing here is that I'm just getting a choice. Getting a choice means I'm choosing some 10 elements from my leg underscore array, and I'm seeing the mean of these arrays. So this command alone will choose some 10 arrays from the leg array. Okay, so if I give like this, you can see they have selected some 10 elements. Okay, so if I want to see what is the mean of these 10 elements selected, I'll just say the mean of this thing only. So you can see now here, when I have given the choice of elements as 10, your mean is coming as 0.021. Okay, so immediately I'm just changing the choice of elements. I'm taking some 100 elements from the leg underscore array, and I'm just seeing the mean. So you can see the mean is now 0.04 actually. Okay, so you can see now as soon as I'm increasing the number of elements of the random array, the mean, our mean is coming closer to the whole mean. So this is now, you can say this like an population mean and sample mean. You might have studied this in your statistics. So whenever I am choosing some elements and finding its mean, and when I'm increasing that number of elements, it's increasing actually. No, sorry, it's the mean is coming close to the population mean. So I'm just increasing the number like 500. So now it has come like 0.023. Okay, So it's coming closer to this, just like it has gone the other way only, but it is coming closer. Okay, so if I keep on increasing, at last it might come near to this value. Okay, now I am just doing another thing actually. So I am just the operation which I've seen there, I'm just doing it again actually. So if I'm taking some numbers from this 0 to n, this is for changing the result actually, and I'm putting the same np.random.choice, this mean, I'm putting it like some average, and then I'm adding this every time. Okay, so if I do that, if I'm giving the number 40, I'm getting like this one. If I'm giving the number as 100, so this one is like I'll choose a random array with 100 elements, and I am repeating this same process 100 times. So after repeating all these options, and I'm finding the mean, and what will you get, you'll see. So at this portion I have taken a choice of 100 elements one time. Okay, now all these selections, this 100 times, this one selection is repeated 100 times. Okay, so it's like 100 into 100 thing will be coming. So if I'm doing that, I'm getting the average actually. So I am just some average I'm adding every time and divide by n, then I am seeing the mean itself. That is the intention behind. So you are getting like it's every time it will be changing also, because we are randomly selecting, so it's getting like 0.01. okay, so somewhere coming close to the other one. So this, in various applications, we need to, like assigning weights in artificial neural networks, arrays need to be initialized randomly. So this is the random nature which happens in many artificial neural networks, that has given to the observation that the weight initialization and assigning will change every time that we run a program. Okay, now for this purpose there are various predefined functions in Numpy, and we have just seen how to make use of reshape and rand functions. Okay, next we'll move on to Numpy indexing. Okay, so here in indexing I'm just naming this particular numbers from 10 having 10 values ranging from 0 to 11, and I'm storing it my m.arr, and I'm printing it, and I want to extract the first element from that array. So I'm just giving my arr in square brackets 1. So if I do that, I'll print the first element. Why the first element is 1 here? Since the indexing of the Python indexing starts from 0 actually. So 0, 1, 2, 3, like that it's going. So the first element will be 1 here. Okay. Now if you want to access more than one element of an array, you can use the slicing operations. So just I am putting the same array here, and I am just displaying the full elements of the array. So these are the elements of the array. I just want to take elements from indexes 1 to 5 actually. So what I can give is like, if I put 1 to 5, I'll get 1, 2, 3, 4. Okay, so I just given like from index 1 to 5 actually. That means that 5 won't be included. Okay, if you want to include 5 also, then you have to give the higher index for that. Okay, the last, so in this case the first element extracted will be of index 1 actually, and the last element extracted will be of index, the one we have specified, -1 actually. Okay, now if you want to access the elements of ranging from index 8 onwards, can you tell me what you have to give? Can you type what you have to do there actually? I'll just start the typing actually. You just say how I should proceed. Okay, if anyone can type what is the command to be given, you just type here, type there. Okay, I just want to access the elements ranging from index 8 onwards. Okay, so those who are there, you just you can unmute the mic and tell, or you can type in the chat window. Is anyone there? I just want to get the elements from index 8 only. Okay, so what you have to do for that is, like, I just have to type 8 and the starting number is 8. I haven't specified any ending number, so I just have to give ARR 8 semicolon, no, 8 colon. I have to leave just like that. Okay, so it will give you the elements starting from the index 8. Okay, now if I want to get all the elements ranging till index 6 excluded, now then I have to not give anything in the starting thing. I'll just have to give the ending element, and if I run this one, I'll get all the elements till the index 6. Okay, now next one, the thing is that NumPy arrays are mutable. That means that you can change the values of the array. So if I've just given like my ARR 0 to 5 the elements I am accessing. Okay, that means that starting from index 0 and excluding the index 5. Okay, I am putting all the values in that range as -5. So if I run this particular program, I'll get like this one. Okay, so starting from index 0, 1, 2, 3, 4. Okay, so up to 4 I have changed the elements as -5, and the rest of the elements are kept as same. So this shows that NumPy arrays are mutable. Okay, now the next one is like arr.np array. I am just doing a reshape for this one. Okay, so I am just giving like np.array. I'm doing the inputting all these elements, and then I'm printing this one. Then I'll get arr underscore 2d as this array. Then I'm just accessing these elements. So in this case, what I'm doing is that I want to get the elements with index. So this first thing represents the rows, and the second one represents the columns. Okay, so I want to get rows with indexes 1, 2. I haven't specified, I have just specified the step size only. Okay, and the next one also starting from 0th column, I haven't specified the ending, and I've just specified the step size. Okay, so here you can say like, if I give according to this one, then the array starts from row index 1. So row index 1 means this 3, 4, 5 row. Okay, so in this row 3, 4, 5, that row, and step size of 2, that means the next row will be excluded and the row after that will be selected. So this row, this first row and the third row will be selected if you give the command like this. Okay, now next one is like the columns. So 0th column I have specified, so this 0th column, this one will be there, and I have given a step size of 2 also. So 0, this middle column will be omitted, and the next third one, okay, that will be selected. So if I run this thing, you can see that the second row 3, 9, that row is there, and since I have omitted one of the columns also, you're getting 3, 5, 9 and 11. Okay, now if any of you can answer me, if I just want to see, or I'll just show one more example actually. If I just type ARR underscore 2D, then I just give like I just want to access the element present at the 0th row and the second column. So just I can immediately give like 0 comma 2. Okay, so if I do this, you can see that this is the original one in the 0th row and second column. Okay, so this is the element, so you can get it like that. And this is, if any one of you can type this, you just have to access the elements from rows first and seconds and columns first and second. Okay, so what you have to give to access those? Okay, the result should be like 0 1 3 4 that you have to obtain. Okay, so what you should type here so as to get this specific result actually? Can anyone type there? Okay, can someone respond please? If it's wrong also, it's okay. That's how we'll all learn. Okay, I'll also give, next time you should respond actually. If I give like 0 to 2 and I just want the top 2 rows, I mean the first 2 rows and first 2 columns only, so I'm giving like rows from 0 to 2 so that 0th row and first row will come. Okay, Shanu has typed 1 to, okay, I'll just type that one actually. Shanu has given me 1 2 3 and 1 2 3. Okay, so if I just run this one, you can see I'm getting 4 5 and 7 8. Okay, so I want to get first and second row. Okay, that's right, and first and second column. Okay, that's right only. Now if you want to do some other way actually, okay, for example, if you want to do just tell me how I'll get 1 2 4 and 5. That, okay, that these elements actually 1 2 4 and 5. Okay, that's easy only. One, 2, 4 and 5 means what? How many rows are there? First and second rows are there, 0th and first row, those 2 rows are there, and columns also, the first and second columns are there. Okay, so the same thing I'll copy here, and what changes you have to make is that I want to get 1 2 4 5. Okay, so you can do it many different ways actually. I'm just doing like for rows I'm specifying, since I need 0th and first row, then I'm giving like till 2 actually, till row 2. So the second row, 0 first and second, in that second row won't be included. And for the other one, for the column, I'll be specifying like I want from columns 1 only. So if I run this one, you can see that I am getting like 1 2 4 5. Okay, so you can work around many these things and you can check how to get all the different values actually. Okay, now through these examples, now we have seen that we can access one or multiple elements of an array using slicing, and when needed we can extract sub-arrays from an array. Okay, next we are moving on to the conditional array indexing. So in this we'll see how to filter an element of an array based on some conditions actually. Okay, so here I'm just giving ARR equal to 1 2 3 4 5, and if I give like I'll just run this and show. If you give it directly like this, it's not possible. Okay, so that's why I just for showing you I'm just put that here. And what you have to do is you just have to make it an array. Okay, so here first this is a list actually. Okay, so directly for a list, if you give like, if you want to find out the elements of that list that are greater than 2, so you can't do this actually. You can get the type error. This is not supported between instances of list and int, so this is not possible for running. This is an error. So what I have to do is like I have to first transfer it to an numpy array. Okay, and I'm storing it in the name array. So first I'm just printing the elements, and now if I give like array is greater than 2, so since after I'm making that as a numpy array, next if I do that array operation, you can see that whatever elements are greater than 2 it will show as true, and the ones which are not greater than 2 it will show as false actually. Okay, now similarly I'll just want to see the length of an array actually. Okay, so for that what you have to do is that I'm just using an array range between 2 to 15, and I'm displaying the elements, and for finding the length I'm just putting len of this thing. This is will be seen in the Python basics itself. So if I do like this, you will get an array length of 13. Now for this particular array, now I have stored ARR as this array containing elements from 2 to 14 actually. Okay, 15 is excluded there. So if I want to output the elements, so I'm just giving like just an example. I'm putting this like this one. Okay, so here I'm just putting the elements that have true as the condition. Okay, so here 2 4 and 6. Okay, these three elements I'm giving like ARR true false like this I have given. So in this, from this I want to see which all elements have been specified as true. Okay, so here you can see that in the position of 2 actually true is coming, then 4 6. Okay, now I'm just change this one. I'm just seeing it again actually. I've made the other things true, so now it's coming like these elements from 9 are having the true values. Okay, this you can just go through, and next these are all similar only. I have already explained. If I want to get numbers greater than 8, then for in ARR it's displaying as those which are greater than 8 is displaying as true. Now if I want to output the actual values which are based on the condition, so here it will just show which all elements are greater than 8. Now if you want to get the actual elements which are greater than 8, now you have to give like ARR greater than 8. So here you'll get the actual elements. Okay, now if you want to get the elements present at index 1 and 4, you can do like this. All these are similar only, and elements which are true as condition, that one. Okay, next we'll move on to the different conditional operations. So this you can, these all you can see with the different examples that I've shown here. Okay, I've just used greater here. Similarly, these are the different things that you can use. Operator equals, not equals, less than or equal to, greater than, equality, inequality. Okay, all these things you can use. Then the next one is numpy array operations. Okay, so the first one is numpy broadcasting. So this describes how different numpy treats arrays with different shape during arithmetic operations. So just see this one. I am putting first array of 3 elements. I am putting np.array 1, 2 and 3. Okay, and second array I am putting like this one. So I am just seeing the multiplication between these two. Okay, so when I multiply, you can see that 2, 4 and 6 is coming. That is no problem is there in this operation. Okay, because both are of the same size also. Now I am just doing this one. Okay, numpy broadcasting rules, it relaxes. So in the simplest case, the two arrays should exactly have the same shape. There is a broadcasting rule which relaxes this constraint. Okay, so we can see what happens when an array and a scalar value are combined. So this is that example. I'm just combining an array and I'm putting b value as a scalar, and if I'm just multiplying it, you can see the same operation is getting resulted here. So earlier I have used 2, 2, 2 and formed an array. That is not required. I can just put a scalar also, and if I run that, I'll get the same. Okay, so the general broadcasting rules are given in the numpy.org website actually, so you can go through them for the different broadcasting rules. Okay, I've just given in the notebook also. Then you can just see next one. I have initialized an array of resolution 4 by 3 actually. Okay, and I'm doing a scalar with value constant 3, and I'm just printing the array shape and the output. So the shape is coming as 4, 3 and the array is printed there. Okay, now if I just do this operation, I want to do the sum of ARR 2D and the scalar. Okay, you can see what happened here. So if you do something like this, if directly a scalar is added, what the numpy does is that it is stretched. Okay, we have just given the value 3. Okay, so if this particular operation is done, what will be done is that a 4 by 3 array will be formed with the element 3. Okay, and what here we will do that for each of the elements of this array, the other one will also be broadcasted as a 4 by 3 array with the element value 3. So direct addition can be done, otherwise it's not possible. So these are the broadcasting relaxations that are present in numpy. Next, you can see just I'm creating a 1D array, np.array like this, and I'm seeing the size and I am outputting the 1D array. Okay, now both these arrays you observe, array underscore 2D is a 4 by 3 array, and array underscore 1D, it's a 1D array actually. Okay, of shape 3. Now you can see what happens when I sum both of these. Okay, so how here it has taken place is that 4, 5, 10 like that it's happening. No, so one of the parameters is same. The first array has 4 rows and 3 columns. The next one is like there is 3 what you say for that, there are only these elements actually, 10, 10, 10 actually. So what I'll show you this example actually. So here if our array is 0, 0, 10, 10 like this is one array, and the next one is 0, 1, 2. Here this is the normal operation only, direct addition is possible, and you will get the output like this. Now the next case, if I am having 0, 1, 2 only, how it will be changed is like these values will be broadcasted means that wherever there is no element, that same element will be replicated. So here the first array had 4 rows and 3 columns. Here only 3 columns were there. So to make it 4 rows, the same elements will be copied to the other rows and then the addition will be done. Okay. Now in the case where both are 1D arrays only. Okay, the first one 0, 10, 10, 20 and 30, and the next one 0, 1, 2. Okay, so in this case what happens is that here 4 rows are there and for the other one 3 columns. So the first one will be copied and made 3 columns itself, so it will be coming like this, and the second one will be made, it needs 4 more rows actually, so it will be copied again 3 times and the full structure of both the arrays will be coming, and next the addition operation will be done. Okay, so these are the broadcasting operations. So from the above image you can see how the data is stretched to carry out the mathematical operations, and here we have performed the addition on varying dimensions. Okay, now just say that I am putting the ARR as this array. Okay, and this is a 2D array also because the number of consecutive brackets are 2 actually. Okay, so I'm just outputting this array and I'm just seeing its shape. Okay, so this array is of the dimension 1, 4. That means 1 row and 4 columns. Okay, what is the shape of our array 2D? Our array 2D has the shape 4, 3. Okay, so this is the shape of this one, 4, 3 of array 2D. I'll just print the shape of that also for easy observation. So I'll just put it here. Okay, so if I'm putting that, you can see that shape of I'm just doing it. Okay, yeah, if I do like this, you can see that the ARR has a shape 1, 4 and our array 2D has a shape 4, 3. So now if we try to do this thing, what will happen? Can anyone guess? Earlier one of the dimensions were coming equal so that the other dimension can be copied. Okay, so in this case you can see the first case number of rows and columns were like this. Here the number of columns is coming equal to the first one. Okay, now if both are 1D arrays, it's no problem, you can extend it to do the one required. But here in this case you can see that first one has 1 row and 4 columns, the next one has 4 rows and 3 columns only. So if you try this one, it's not possible actually, and if I execute this one, what you will be getting is like operands could not be broadcasted together with shapes, this one. Okay, so this particular operation is not possible. Okay, so you have to see the dimension. If the dimensions do not match, it will throw an exception. It is advisable to keep a note of the shape or dimension of the arrays and make sure they satisfy the broadcasting rules. Okay, next we'll move on to the mathematical functions. So these are the different mathematical functions which are present. We'll see one by one. So these are you can see it clearly. If you want to do the minimum, get the minimum value of in an array, you can do min of that function. Okay, so here you have to place the square brackets also for calling this type of function. So if you do this, this is pretty explainable only. The minimum returns the minimum and maximum, then arg minimum, it will return the indices of the minimum values, and arg max will return the indices of the maximum value. Then the next one is square root, mean and exponential. Okay, so all these if you want to see the minimum index, maximum index and mean of the array, you can give like your specific array name dot this function. Okay, now if you want to see the square root, the command is little different actually. So I'll just copy this one and see what happens here. So print the square root. Okay, so I have just given the next one also, square root of elements can you wait just for a moment? Ma'am, you are presenter also. Okay, sorry for the disturbance. I'll just come back. So next one, the square root of elements. If I want to see that, just like the other one, if I give, you can see what happens here. arr.sqrt. Okay, this is just for showing you what will happen. So you can see that np.ndarray, an error has come up, has no attribute square root. It is downloaded already. Okay, I've just gone between, sorry. So I've just given us the error here like this. I've got the error like this. So what you have to do in this one is that you can't give the command like this, arr.sqrt, like this you can't give. So what you can see is that if you put the square root of elements of an array, np.sqrt of arr, you can get the square root of elements in this array. Okay, so what you have to see that always the command might not be the same for everything. You were able to find out the minimum and maximum, all these things, using this type of format, but if you use the same format, you can't find out the square root. Okay, for square root you have to give np.sqrt of square root of which array you have to find, you have to specify inside. Okay, similarly the exponent is also present. If you want to find out the exponent also, you have to give np.exp of arr. Okay, next I'm just giving an array like arr and I'm forming the numpy array. Now if I want to find out where the minimum value is there, okay, so I'll just run the first one. Actually, we'll see what is coming. So I just want to find out where the minimum value is coming. Okay, so what is the minimum values here? The minimum value is 1. Okay, minimum value in this array is 1. So where the 1 value is coming, if I want to find, you have to just give arr equal to where the minimum value is coming. So it has given like in 0 and 2 the minimum value is coming. So if I want to see something else, like if I want to see the first element where the minimum value is coming, so the first element where the minimum value is coming is in the 0th index. Okay, so these are the different operations. You can find out the different ways where you can do this actually. If my sound is not audible, please tell me. Okay, now the next one is array manipulation. So here what we can do is like we can do the arrange, reshape, flatten and transpose. So arr equal to np.arrange 0,16, and if I output this array, you can see what is there in that array. Okay, now I'm just reshaping the array as a 4x4 matrix. So I'll get like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, now if I transform this 1D array to 2D array to a 1D array, what I have to do is that I have to just give the command flatten. So I am just giving the name of my arr.2d and I'm giving flatten. Okay, so if this is given, then I'll get the same array which was reshaped as a 4x4 array is being flattened to a 1D array. Okay, now the arr.2d, that is an array with the shape 4, 4. Okay, now if I do the transport, this is the array right now. If I run this particular command like transpose, you can see that the transpose of this particular array is taken and displayed. Okay, so this is how reshape, flatten and transpose works. Next one is array merging and splitting. So here the next things are concatenate, edge split and vertical split. So here we'll see what all that one by one. So arr._x np.array, I'm just giving these elements and storing them at this value, and I'm giving these particular elements and storing it as arr_y. So if I run this one, you can see these both are stored. Actually, I'm not displaying it right now. Now after this, what I'm doing is that I want to concatenate these two arrays. Okay, and I'm giving the access value as 1. 1 means I'm concatenating these arrays column wise. So we'll just see what the result is. Okay, so I have kept the first array in these particular columns. Okay, and the next array is added column wise actually. Okay, so that means that the first array is kept first, next the next array's columns are actually added. Now if you want to stack the other both the arrays one after the other, stacking means on top of the other, then the rows should be changed. So if you want to change this actually to row wise, okay, so if you want to change this row wise, what you have to do is like you have to see the column axis equal to 0 and concatenate these two rows. Okay, so you can see the output of this one. I'm sorry, I didn't change the namings actually. Okay, so if I do that, you can see how it is changing. Okay, a repetition is there. Now next one is like horizontal split and vertical split. So these one will show you how the horizontal splitting as well as the vertical splitting is happening. So for that I am taking the row wise concatenated matrix, row wise concatenated array actually, 2D array actually. So here what I am doing is that I am using the command edge split. Okay, if I do this, you can see that this particular array has been split like this, horizontal split. Okay, now the next type is the vertical split. If I do the vertical split, you can see that the first two rows will be kept and the next two rows will be made as the other one. Okay, so the split will be done vertically. So you can see that now the concatenation can be done column wise and row wise, and also the arrays can be horizontally and vertically splitted. Okay, now these are the conclusion about the Numpy arrays. Numpy, it's an open source add-on module to Python. You can interface other packages in Python ecosystems, and all these things you can learn and you can see in the notebook itself. So I think many people are leaving, so join once more please, because after 10 minutes I'll be starting the pandas. So we'll take a 10 minutes break and I'll see you afterwards.